Here's my beginning mod of installing the EZ controller board. For LED lights. I bought these little strip off of All Electronics. I think it was $1. They run on 12 to 15 volts. So I kept the initial board that was mounted behind the meter and just disconnected everything except for where the Zener diode was that provides voltage, and then I added a 2K resistor to drop the voltage down for the lights. And you can see I've removed most of the wires, and here's what it looks like when it's lit up. Just bright enough to see all the indications. So it's a cheap little mod, cost $1. I mounted the EZ controller board underneath. Makes it easier to troubleshoot. I added some IC sockets for the other ICs, and here's the little mod I did to the board. And where the meter wires come out, I still use those attachment points, but I just soldered a white and black wire which goes over to the meter there. I did have to tilt the pots a little bit since I added the sockets. They were blocking the pots a little bit, so now I'm getting ready to wire up the rest of it. Okay, I've completed all the wiring and added a little green tie wrap there for strain relief so you can't pull out the RS-232 cable, and getting ready to power it up. All LEDs are here, and there's my antenna rotor. So let me shoot the juice and give it the smoke test. Okay, turn the power on. LED lights come on. Green light. Let's see, we'll hit brake release and go clockwise. Okay, go counterclockwise. That seems to function. Okay, we will go to, and there's the brake delay. Let's go to 300 degrees, and it goes back one way, releases tension. Red light shows that it's operating. The other red shows the brake release, and it stops. Okay, we'll go the other direction, and you can hear the brake energize. Okay, we'll go east, and go back. Clockwise LEDs on. Goes to east. A few seconds later, you'll hear the brake release click. Light goes out. So, initial test. See, we're pretty successful and no smoke. So, let me get on to the procedure of calibration. Okay, the calibration is done. You can run it counterclockwise here, and you'll see the needle will keep on going until we get to the south stop. Almost there. Bam, she stopped. Okay, then we'll go the other direction, counterclockwise. Kind of like watching paint dry. But it's getting there. And the meter south. Okay, then we'll do it automatically. We'll move the calibrate button, which is now the preset button, and we'll just say we'll go to north. We'll hit brake release. And there it goes. Clockwise LED is on. Brake release is on, showing it's released. And the tricolor is kind of supposed to be yellow. And actually it goes from, as it meets its midway point, it goes from yellow and then it goes to green and stops. So it's all calibrated. Brake just went on, and now we will try set up to the RS-232 port. Okay, I've got the Ham4 rotor with the EZ rotor control hooked to a COM port on a Windows 7 Dell machine. And before I bought any programs, I downloaded LP-rotor and put on COM port 1, and it appears to work. Now I'll go to set it to 0 here, hit go, and there it's going. Rotor's turning, meter's moving, says north, and 0 degrees and kerchunk. The brake set. Let's go to 180 degrees. Go to 180. Actually, it's 183. That's pretty sensitive. 177. Okay, and go. And we're heading off. There's several programs out there. I could just pick one, and as I get into this, I'll probably find something a little better with a larger display. And there we go. And it's a degree or so off, but that's close enough. So that's a wrap. Got the rotor control board put in, all hooked up, and now it's time to hook it up to the different rigs I got here. So that's it.